All right. Good afternoon, grade 12s and 11s. So unfortunately, I had to book off sick today. So we're just going to go through, I'm just going to go through this lesson here um, filmed. So hopefully we can follow along with the lesson here today. I should be back tomorrow to answer any questions that you might have. But I am going to go through our lesson 3 here, and we will proceed with our plans to have our quiz this Friday for this unit. Okay, so I'm just going to finish off with what we had yesterday. Okay, yesterday basically we've talked about degree and we've talked about leading coefficient, okay, of a polynomial function. All right, for example, I'm going to write a little example down here. But let's say I have a function f of x equals, let's say, 2x to the 4 minus 3x3 plus 2x plus 4. Okay, that's an example of a polynomial function. The degree here is even, or degree 4, okay, because our highest exponent is 4. So this is an even function. So if we wanted to talk about our end behavior, it's going to be either this type or this type. Now, this is true for all even functions. The second key piece of information we look for is our leading coefficient. We want to determine if our leading coefficient is positive or negative. In this case, it's positive. So this function here the end behavior is going to act like a positive or a parabola that opens up. It's going to, we could say, start high and end high, or talking about what we talked about yesterday, as x approaches negative infinity, y approaches positive infinity, the left side. So, right, this refers to our left side, and this refers to our right side. So as x approaches positive infinity, our y also approaches positive infinity. Okay? Let's say I were to change our function, and maybe I made it negative. Well, now it's still an even degree function, but now the leading coefficient is negative. So now this is it's similar to a parabola, okay? It acts like a parabola, and it's a parabola that's going to turn or open down. So it starts low and ends low, we could say, or as x approaches negative infinity, y approaches negative infinity, and as x approaches positive infinity, y approaches negative infinity, or we could say that's down. As soon as we change our degree, so let's now say that, okay, well, now our function instead is, so we still have 4, but now we have f of x equals x to the 5. Well, now our degree is a 5th degree, and 5 is an odd number, so it's an odd function. Our leading coefficient in this case is positive, so this function is going to act like our positive linear function. It's going to start low and end high. Or as x approaches negative infinity, y approaches negative infinity. And as x approaches positive infinity, y approaches positive infinity. Okay? As soon as we make it negative, if we were to make that leading coefficient negative, it would be the opposite. So it would look the opposite. It would start high and end low. Okay, start high and end low. So as y approaches negative infinity, as x approaches negative infinity, y would approach positive infinity, and as x approaches positive infinity, y would approach negative infinity. Okay, so it's important to note here and kind of recognize, well, those are the 4 cases, and the end behavior of an odd degree function are in opposites directions, and the end behavior of even degree functions are in the same direction. Okay, so this is important to remember. Whenever you look at a function, if you figure out the degree and the leading coefficient, you'll have a general idea of what that function is going to look like. Now today we're going to get into a little bit more characteristics of polynomial functions. And today we're going to focus more so on when we look at a function in factored form. Okay? So apologize because I did say that yesterday I would bring in some photocopies there from part of yesterday's note. I will still plan on bringing those in tomorrow, but unfortunately I'm away today. So what we're going to look at here is we're going to look at what we call multiplicity. Okay. And I might actually open Desmos up for a little bit of this to kind of try and show you some examples. But I'm just going to read through the definition, and then what I'll do is, again, I'll go through a bunch of examples so you can see kind of what I mean by multiplicity. Okay. Multiplicity refers to the number of times a factor appears in a polynomial function. Okay, how many times does a factor show up? And it tells you if the graph, so we have two cases, crosses the x-axis or touches the x-axis and turns around. Okay, so what do I mean by that? All right, well, let's actually, you know what, I'm going to open up. So basically what we're looking at is even multiplicity versus odd multiplicity. So I'm going to open up some Desmos here. Let's grab Desmos. And I'm going to type in a function here. Okay, let's try this out. Where's my Desmos keyboard? That was hiding it. Okay. So let's say y equals. And so I'm going to write out a function in factored form. We're going to start with x minus 2. Okay. So notice here, what makes that bracket 0? What makes that bracket 0? If I sub 2 into that bracket is 0. Notice that refers to my x-intercept. Okay, the value that makes that bracket 0 refers to my x-intercept. Now let's say, and how many times does that factor show up? How many times does x minus 2 show up? It shows up only one time. Let's see what happens if I type out here. And and notice what happens at x equal to 2. Notice that our graph passes through that coordinate. Now watch what happens if I add that factor again. So x minus 2. So now this factor happens 2 times. So we say that because it happens twice, we say that it has even multiplicity. Now let's go look at what it means for even and odd multiplicity. So even multiplicity is an even number of repeated factors, which we have because x minus 2 happens 2 times. Okay, and what happens when we have even multiplicity is it touches the x-axis and turns around. Now let's go back and look at that. It touches the x-axis here and turns around. Now let's say I do another one. Let's say I put x minus 2 again. So now that factor appears 3 times, or an odd number of times. Odd multiplicity is an odd number of repeated factors. So this happens 3 times, so it's an odd number. And when you have odd multiplicity, it's going to cross the x-axis. So notice here that our graph crosses the x-axis at x equal to 2. Okay. Now what we can do is we can look at this a little bit more in depth, because if I were to write x minus 2, x minus 2, x minus 2, I can make that a little simpler, right? I can write that this is the same as x to the power of 3. I get the same graph. Okay. Now let's create more x-intercepts. Let's do, what if I had x plus 1? Okay. Notice that the plus 1 factor has odd multiplicity. So at negative 1, it passes through. Now let's see what happens if I make that x plus 1 squared. Notice now it bounces off the point. because that factor occurs twice, right? X plus 1 squared is the same as saying x plus 1 bracket x plus 1. Now those are the exact same thing. Let me just do this here, right? We have the same graph, okay? So that's the same thing. It bounces off. So I'm going to go back and I'm just going to write this as back like this. Now let's say, what if I make it cubed? What's going to happen? It passes through. Let's see what happens if I make it 4. It bounces off. 5 passes through. 6 bounces off. 7 passes through. 8 bounces off. 9 passes through. 10 bounces off. Notice it gets flatter and flatter, but it's still, if I were to zoom in, now let's see if I can zoom in a lot, it does actually bounce off. It's just really, really, really close. See, notice how it's not touching. Where are we here? See, it's getting very, very close. Very, 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 very close. So close. And actually, if I zoom right in, we'll see that at -1, watch, I have to zoom in a lot. I don't know if we're actually going to see it. We're not even going to see it. We have to go too close. Unfortunate, but you get the idea. It does bounce off at that point, okay? Because it's even multiplicity. So that's what the multiplicity refers to. It basically refers to kind of the exponent on a factor or the number of times that it occurs. So let's continue. X-intercepts of a polynomial function are the zeros or roots of a function that make the value of a function 0. Okay? So let's go take a look at these. We've got a bunch of examples here. So I'll give you a second. Hopefully you can maybe copy that down. If at any time the teacher needs to pause the video so you can get something copied down, please just raise your hand. So let's go through here and write out, kind of go through, talk about something. So polynomial function in factored form. We have a bunch in factored form. Write the factors that repeat an odd number of times. Write the factors that repeat an even number of times. Determine the x-intercepts or real roots. And write x-intercepts or zeros in which the graph touches and turns around. Well, which ones occur an odd number of times? Well, they both only occur once, and 1 is an odd number. So the ones that occur even number of times are none. Determine the x-intercepts. Well, what makes the first bracket 0 is 2. What makes the second bracket 0 is -3. Are there any points where the graph touches and turns around? No, because if I were to type this in, let's do that. So let's try this. Let's go bracket x plus 2 and no, I think I might be typing this in wrong. X minus 3. Maybe I did that the wrong way, but notice it passes through at those points. It doesn't bounce off. Okay, so we'll say none. So we have another one. X plus 2, x plus 2, x plus 2, x minus 3. X plus 2 occurs an odd number of times. It occurs 3 times. And x minus 3 occurs an odd number of times. There are none that occur an even number of times. And our x-intercepts are -2 and +3. Let's take a look if there's any points that bounce off. I'm going to warn you, there are none. So x plus 2, x plus 2, bracket, x plus 2, bracket. Oh wait, I typed in one wrong. That should be plus. Right? Those are all the same. It passes through at both of those points, at -2 and +3. Okay? How about the next one? x minus 1, x minus 1. So that's an even number of times, x minus 1. X plus 1 happens an even number of times, and x minus 4 happens an odd number of times. Your x-intercepts here are negative 1, 1, and 4. And where do the bounce points happen? At x equals negative 1 and 1. And we can check that. So 2 minus 1s, 2 plus 1s. So we're going to go x minus 1, x minus 1, x plus 1, plus 1. I'm just going to square that one. It's the same thing. And the other one was x minus 4. Okay, so notice it bounces off at the positive 1 and the negative 1, and it goes straight through the 4. Okay. This one here, we can probably starting to see a pattern here, but x plus 2, because it's to the power of 4, happens an even number of times, and x minus 2 happens an odd number of times because it's to the power of 3. Our x-intercepts are negative 2 and positive 2, and let's check if we have bounce points. Let's clear that. So I think it's something like x. No, I'm not sure yet from x plus 2 to the power of 4. And the other one was, x minus 2 to the power of 3. Okay? Notice it passes through and bounces off. Okay? So it bounces off at negative 2. And that's because of the even number here and odd. Straight through, bounce. I like to call these bounce points. Okay. So the graph of a polynomial function touches the x-axis and turns around at each x-intercept or 0 that has even multiplicity. The graph of a polynomial crosses the x-axis at each x-intercept that has odd, so it goes through. The graph will cross the x-axis at any single root 0. Okay, the graph will cross the x-axis at any single root. So that just means single root means like x plus 1. That's a single root. Okay. All right. So this page here, let's see here. These 2 pages, okay, these 2 pages here, I am going to print off for you. Okay. So what you can do, I'm not going to print many things, but for the sake of today, these 2 pages I'll have printed for you. Hopefully they're printed today. If they didn't get printed today, so I'm going to send an email, try to get them printed for class. If they're not printed today, I'll have them to you tomorrow. But this is kind of what's important here. So we're looking at steps for sketching polynomial functions. So there are a few steps here, and that's kind of what we're going to look at. We're going to look at some examples. But the very first step is we want to find the y-intercept. Well, how do I find the y-intercept? I sub in x equal to 0. We always do that. That's always the same thing. The second thing we're going to do is find the x-intercepts. Now, how do we do that? We look at it in factored form. Okay, now these are all going to be given to you in factored form. So we look at each factor in particular and determine what makes that bracket or that factor 0. Okay, so for example, if I had x minus 3, my x-intercept is at 3. Because if I sub 3 into that, I get 0. The next one here says identify the degree and leading coefficient to tell us end behavior. As soon as you know each of the, we need to know if it's even multiplicity. Once you know those 3 things, you can sketch a graph. That's all you need to know. Now, end behaviors, well, we have our little chart there, so that's important. Okay, you can think of it that way, or here's another way to think of it. Odd degree, if your odd degree is positive, odd degree positive, the graph starts low, ends high. Okay, so think of that like this. I'm going to I'll sketch each one of these. So, odd positive, think of y equals x. Odd negative, think of y equals negative x. That's an odd degree, right? X to the power of 1. Even positive, think of y equals x squared. Oh, that's really poor drawing. Whoa. Starts high, ends high. And last one, even negative, think of negative x squared. Starts low, ends low. Okay? That's an easy way. That's kind of helpful for remembering, but it is important that you know the notation. Okay, the notation is also very important. Now, this is totally optional, and for the purpose of this video today, I'm not necessarily going to show you. Actually, you know what? I can show you quick here. Basically, what we would do here is we would identify, okay, where are my x-intercepts? Here, it's at -3 for this one. It's at +1, +4, and +1. My bounce point is at +1. I always put an X where there's a bounce point, so it reminds me when I'm sketching. Now, basically what you would want to try here is it says try numbers, so you test numbers. So put in a number that's less than 3, maybe x equals -4. Put in a number in between -3 and 1, so maybe x equals 0. Put in a number in between 1 and 4, maybe x equals 2. And a number greater than 4, maybe x equals 5. Sub those numbers in and see, do I get something positive or do I get something negative? That'll help you determine where exactly your graph is. Is it above the x-axis or is it below the x-axis? So if I sub in -4, I'm going to get, well, -4 minus 4 is a negative, so negative. -4 minus 1 squared is a positive, -4 plus 3. So I get negative, positive, negative. So my graph is going to be positive here, or above the x-axis. If I sub in 0, I get 0 minus 4, that's negative, 0, that's positive, I get positive. So this is a negative region. Because I get negative, what do I get? I get -12. I get -12. I sub in 2, I also get a negative. And if I sub in 5, I get a positive. So basically what that means is that my graph is going to look something like this. It's going to start up here. It's going to come down through this x-axis, x-intercept. It's going to stay negative, and then it's going to go up here. Okay? So that's a rough sketch of what my graph would look like based on subbing some values in and it telling me if the graph is above the x-axis or below the x-axis. Okay, that's all that means. Positive means f of x or y is above 0. Negative means f of x is below 0. So let's graph. This page here is actually fantastic. This is super helpful because it basically gives you a bunch of sketches of what these functions will look like. So you can read through this page on your own, but it's a good refresher of everything that we've talked about. Okay, so I would recommend reading through this. What I will do is I'll kind of go through this, make sure I'll answer any questions about this stuff on Wednesday. Okay, so if you have any questions, read through this. It's super helpful information on this page, kind of a summary of everything we've talked about so far. Okay, now let's sketch. All right, first thing I want to do is find the y-intercept. So step 1, y-intercept. So I'm going to sub in x equals 0. So that means I get 0 minus 1 is negative 1, 0 plus 2 is 2, and 0 minus 3 is negative 3. That is equal to 6. So my y-intercept is 1, 2, 3, 4, 5, 6. So y-intercept. Second step, x-intercepts. What makes each bracket 0? X minus, what makes the bracket 0? Well, the first one, x equals to positive 1. So draw that one. Negative 2 makes the second bracket 0. Right here. So negative 2, positive 1 would make that 0, and positive 3 would make that 0. Okay? Now, any even multiplicity, there's no even multiplicity, which means no bounce points. Second and last thing here, end behavior. Point 3. So I look at my degree. So my degree and my leading coefficient. My degree is 3, right? 1 factor, 2 factor, 3 factor, or x's, we just look at the factors, and if there's any exponent on the x's, and my leading coefficient, well, that's a 1. Oh, shoot. 1 right there times 1 times 1, the coefficients on each x. So my leading coefficient is positive. So an odd positive, if I think about that, odd positive looks like this. So it's going to start low and end high. So my graph is going to look roughly like, whoa. Okay, so we're going to start low. I'm going to start low. Start low down here. End high, like that. There's a beautiful sketch of my function. Okay. Next one. Okay. First step. Step 1. Whoa. Step 1. We want y-intercept. So I'm going to sub in 0. So if I sub in 0, I get y equals, well, negative 2 stays the same. 0 plus 2 is 2 squared, and minus 1. That's equal to negative 2, bracket 4, bracket negative 1. That's equal to negative, and negative is a positive. That's equal to 8. So let's count it out. 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. Okay. Now I want to determine my x-intercepts. So step 2 is my x-intercepts. Well, let's look at our brackets. What makes this bracket 0? It's negative 2. What makes this bracket 0? 1. So my x-intercepts are x equal to negative 2 and 1. Notice this one has even multiplicity. So even multiplicity at x equal to negative 2. So that's a bounce point. So at negative 2, I'm going to put a bounce. Like I said, I always like to put an X because it reminds me when I'm sketching that I'm going to bounce there. Do not pass, right? We're not going to go through that. And my last step is end behavior. So I want degree and LC. Degree is 2 x's here, so this bracket here is squared, so that's 2, and this bracket is to the power of 1, so that's 3, so this is a degree 3 again. Leading coefficient, the negative 2 times 1 times 1, so negative, it's a negative, so this time it's just the same as our last one. It's odd negative, gonna go this way. Oh, sorry, I forgot to put my other x-intercept. Here's our other x-intercept. So this one here, it's going to start high, end low. Let's see if this works. bounce. Makes sense. You shall not pass. We're going to go up. We're going to hit this point. Then we're going to come back down. There is a sketch of our graph. It starts high, ends low. Okay. Now, some of you maybe are wondering, is this a maximum point? Technically, we don't know if that's a maximum point. It might be, it might not be. I'm not concerned about the maximum points. Okay, we're not determining those here. So just a rough sketch. What's important? Y-intercept, X-intercepts, and end behavior. Those are the only three things that I care about, okay, for these sketches. So those are the only three things that you need to be sure that you're understanding. Three things for a sketch, okay? Let's do another one. All right, again, y-intercept first. So for your y-intercept, we sub in 0. So that's y equals 0 minus 1 is negative 1 to the power of 4. 0 plus 2 is 2 to the power of 2. That's equal to 4. You can sub that into your calculator. 1, 2, 3, 4. Next step. Holy cow, my hand keeps hitting this. Next step is x-intercepts. We look at our brackets. X equals positive 1 for this one, positive 1, and negative 2. Notice that there's a bounce at both x equal to 1 and negative 2. They both have even multiplicity. So here x and here x. This one is, oh, let's look at end behavior. This is step 3. End behavior. Oh, my writing is getting worse. Okay, I apologize for that. And behavior. So we look at the degree and the leading coefficient. The degree here, it's 4 for the first one, 2 for the second. So 4 plus 2 is 6. Little addition there. And the coefficients of the x's, 1 times 1 is positive. So this is even positive. If we think even positive, we think of a parabola. Opens up, starts high, ends high. We're going to bounce. Oh, let's try that again. Bounce, bounce. There we go. Well, W. Okay. Hopefully we're starting to get the hang of this. I got a few more here. What are these ones? Oh, these are practice. Okay. Let me do 2 more here. Okay, so let's try this one. Y equals, we have, ooh, this is an interesting one. Negative 0, 6, 3 squared, negative 2. 0 times all that is 0. So our our y-intercept is here. Sorry, that's our y-intercept. That's our first step. Our second step are x-intercepts, which we figure out what makes them 0. Well, what makes this one 0 is 0. What makes this one 0? Negative 3. Which makes this one 0 is 2. So x equal to 0, negative 3, and 2. Any even multiplicity? Yes, we have even multiplicity or a bounce at x equal to 0. So I'm going to go and put my x there. Right, this one has an even exponent. And then lastly, end behavior. So we look at what is our degree. Erase that. What is our degree? What is our LC, or our leading coefficient? So 6 plus 3 plus 1. 6 plus 3 is 9, plus 1 is 10. Our leading coefficient, negative 1 times 1 times, so it's a negative. So what is this one going to do? It's going to start low, end low, a parabola that opens down. I forgot to, I'm rushing here, so I apologize for that. I'll slow down. 1, 2, 3. There's my other x-intercept. There's my other x-intercept. we can sketch this. That's a rough sketch. Looks like the McDonald's make me hungry. Here we go. All right. And these just get like, again, if you do these steps every time but get used to them, okay? I'm going through them rather quickly now because I've done a lot of these, okay? So it's really important though that you take your time and you understand what you're doing each step along the way. It may not seem like much, but when it comes to test time, if you have not practiced this stuff, you will not remember it, okay? So it's super important that you practice this stuff. One more time. Y-intercept. How do we find the y-intercept? We sub in zeros for all of our x's. So the first bracket becomes 2, negative 1 to the power of 5, 1 to the power of 2, and 4. 2 times 4 that's negative 8. Okay, so negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Hopefully I don't make any mistakes, because if I make any mistakes, this video is permanent and there's no going back. So hopefully I'm doing okay here. I do have my solutions next to me, but what happens is I tend to get going with these questions and I tend to not check my solutions. But let's keep going. So this one, negative 2 makes that bracket 0. 1 makes that bracket 0. Negative 1 makes that bracket 0. And negative 4 makes that bracket 0. So my x-intercepts are negative 2, 1, negative 1, and negative 4. Do I have any bounce points, or what we call even multiplicity? Well, yeah, I do. I have, oh my goodness, I'm dropping my pen. This has an even exponent there, so I have a bounce point at x equal to negative 1 at that x-intercept. So I'm going to put my x there. I also have an x-intercept here. I also have an x-intercept here. I also have an x-intercept here. Then lastly, we figure out our end. This is my third step. And behavior. I feel like this is a long video. I'm not sure. Hopefully, I got to be about 40 minutes in. So it should give you a little bit of time to try some questions. And behavior. What is our degree? And what is our leading coefficient? Well, I'm just going to erase so I can see this. So we have, if I zoom in here, right? Oh boy, what did I do? Oh my goodness. Okay, I apologize. All right, if I zoom in here, let's try that again. 1. Wow, struggle right now. Wow, it just doesn't want to show me. Oh my goodness. Wow. Okay, well, I'm not going to try to zoom in that close this time. The first bracket is 1, plus 5 is 6, plus 2 is 7. Wow. 1 plus 5 is 6, plus 2 is 8, plus 1 is 7. Wow. Degree 7, and our leading coefficient is positive. The coefficients on all of those are positive ones. So what does my graph look like? It looks like this. Starts low, ends high. So let's try this. Starts low, ends high. So we're going to come up, go back down, come back up, bounce, go back low. As you can tell, that is what my graph looks like roughly. Okay. Again, what matters to me is the y-intercept, the x-intercepts, and the end behavior. Making sure that you got your bounce points in there. Last one here. Okay. Sketch the graph of a polynomial function that satisfies the following following conditions. Degree 3, positive leading coefficient. So Degree 3, positive leading coefficient is going to look like this. Starts low, ends high. 2 zeros and 2 turning points. Okay. Well, let's do a 0 here. And let's do a 0 here. 2 zeros, 2 turning points. Well, let's try. 1. There's 1 turning point. I can only have 2 zeros, so there's 2 turning points. Notice how one of them has to be a bounce point. If I didn't do a bounce point, I would end up with 3 zeros. Okay. There's some homework questions for you. Okay. And then I will also... you know what? Here's what we're going to do. Okay, so there are the homework questions. I'll let you take a picture of that or leave that on the board for right now. And then, so there's that for a minute. And then here's the worksheet. So what I would do is just take a picture of these. You can just sketch these. The worksheet doesn't have graph paper on it, so I'm not going to print it for you. But I will take some of these up in class. So sketch the following polynomial function. So there's your first one. I'll give you a second to kind of get a picture of it or write it down. There's the next one. Determine the positive and negative regions. Okay, positive and negative regions. Let's just look for a quick second here. Positive and negative regions of this one. Here's a negative region. It's below the x-axis. Here's a positive region. It's above the x-axis. So let's try that again. I'm going to do positive in green. Positive region, negative region in yellow. If I scroll up, positive region, negative region, negative region, negative region. Positive means above the x-axis, negative means below. Positive, positive, negative region, negative region. Okay? This thing here, let's do this one. Negative region, positive region, positive region. Okay? So, excuse me. So to determine positive and negative regions, you just look at where is it above the x-axis, where is it below the x-axis. Next question. You can try this one, so you can kind of take a picture of this one. List 2 reasons why the function below does not represent a 6th degree polynomial function with a negative leading coefficient. There's probably a couple reasons you could tell me. Tell me what you think. This one says determine the intervals in which the function above is increasing and decreasing. Okay, so you might have to make some estimates. Remember, decreasing means it's going down from left to right. Increasing means it's going up. So you can take a snap picture of that. What possible degrees may the function above represent? Ooh, that's a good question. I like that. And that's all. Okay, it's a big lesson. Like I said, I'll answer any questions that you have when I return. Hopefully and ideally tomorrow. I probably will be back tomorrow. But that's all for today. So let me do a little zoom out there. This worksheet is also posted on OneNote, so you can access that on OneNote. And now the completed note is all there for you on OneNote. So if you want to review that, you may. All right. Have a fantastic rest of your day, and we will likely see you all tomorrow.